Welcome to question 7 of the 2020 TMUA paper 1. The question gives us two equations. Firstly, 2 to the 3x is equal to 8 to the y plus 3, and secondly, 4 to the x plus 1 is equal to 16 to the y plus 1 divided by 8 to the y plus 3. We're asked to use this information in order to find the value of x plus y, and we're given 6 different options. Pause the video here, read through the possibilities, and try to solve this question for yourself. Okay, let's start by looking at the first equation, 2 to the 3x equals 8 to the y plus 3. Well, how can we get any useful information out of this equation? Well, we can notice that 8 is just a power of 2, so we can rewrite 8 as 2 cubed. And why is this useful? Well, from the left-hand side of the equation, we have a power of 2, which is 2 to the 3x. And on the right-hand side, we can use a property of exponents in order to rewrite this just as a power of 2. Because 2 to the 3 to the power of y plus 3 is just 2 to the product of 3 and y plus 3, which is 3y plus 9. So we have 2 to the 3x equals 2 to the 3y plus 9. And because raising a number to the power of 2 is a one-to-one function, the fact that 2 to the 3x equals 2 to the 3y plus 9 tells us that 3x must equal 3y plus 9. And we can then just divide this equation through by 3 to get a more simple equation, which is x equals y plus 3. Can you see how to do something similar with the second equation? Indeed, our second equation is 4 to the x plus 1 equals 16 to the y plus 1 divided by 8 to the y plus 3. What do we notice about the numbers 4, 8 and 16? They're all powers of 2. 4 is 2 squared, 8 is 2 cubed, and 16 is 2 to the 4. So using a similar method to in the first equation, we can rewrite this equation as 2 to the power of 2x plus 2 is equal to 2 to the power of 4 times y plus 1, 4y plus 4, divided by 2 to the power of 3 times by y plus 3, which is 3y plus 9. And therefore, we can again find another equation if we use the property of exponents here, that if we divide a power of 2 by another power of 2, then that's the same as subtracting this power from this power. So we see that 2 to the 4y plus 4 divided by 2 to the 3y plus 9 is just equal to 2 to the y minus 5. So we therefore have that 2 to the 2x plus 2 equals 2 to the y minus 5, which tells us that 2x plus 2 must equal y minus 5. And if we move the constants together, we see that we can write this equation as 2x equals y minus 7. Okay, so now we have these two equations, so let's label them as equations 1 and 2. And these are two equations with our two unknowns, x and y. So what can we do now? Well, we can solve them simultaneously in order to find x and y, and then from that we can find the value of x plus y. So how can we solve these simultaneously? Well, we need to eliminate one of the variables. So if we subtract one of the equations from the other, then we will get rid of the terms of y. So let's subtract equation 1 from equation 2. So on the left-hand side we have 2x minus x, which just gives us x. And on the right-hand side the y's cancel out, we have minus 7 minus 3, which is minus 10. Okay, so x is equal to minus 10. And now if we plug that back into equation 1, we have minus 10 equals y plus 3. So that tells us that y must equal minus 13. So now we have x is minus 10 and y is minus 13. And what we were asked to find is x plus y. So we see that that must be minus 23, and if we look back at our options, we see minus 23 is option A. So our answer to the question is A.